The world is facing a crisis. Mankind is producing waste at a rate of 2 billion tons a year. Worse yet, it's a rate that is accelerating, expected to increase by roughly 70% in just 30 years to nearly 3.5 billion tons a year. It's not just what we throw away as consumers. A great deal of the challenge occurs upstream, where a massive amount of pre-consumer waste is generated in the manufacturing of goods we all use. While citizens in virtually every society and manufacturers in nearly every industry contribute to the problem, you are in a unique position to play a significant role in the solution. Yes, you, because you are in a trend-setting industry, one that can create a massive and meaningful impact on the world's waste problem. How? Consider around 15 to 20% of the fabric used in clothing manufacturing winds up as unnecessary waste on the cutting room floor. Consider that as an industry, fashion uses up even more energy than aviation and shipping combined. Consider many textiles can take up to 200 years or more to decompose in landfills. Consider that instead of 4 fashion seasons, there are now up to 10 in a year, accelerating the rate at which clothes are discarded. Today's most influential voices believe companies should help address social and environmental issues. It's time we stretched our vision. It's time we stretched our thinking. It's time we stretched the limits of what's possible. A new era of fabric and apparel circularity is on the horizon, and Lubrizol is here to lead the way. Pioneering with like-minded partners in our Innovation Alliance, we're paving the way to help you create smarter with breakthrough fiber technology that requires less energy in processing, is solvent-free, and is recyclable, both in manufacturing and in the consumer world. This is a game changer in a game we must win. Seize the opportunity to be a brand that leads the most important fashion trend the world has ever seen. Be a market leader that embraces and drives the change the industry needs and the consumers demand. While the challenge of waste is mounting, it's not insurmountable. Tackling tough challenges is what we do best, working with manufacturers across the numerous industries to help bring about a world in which we all move cleaner, create smarter, and live better. Working together, we can make a real difference in the apparel world. Let's do this. Let's talk. Let's act.
Hello everyone, welcome to our event Stretch the Limits with X4J. My name is Lydia Valcastle and I will be your moderator. Our presenters today are Rob Richardson, Lisa Donofrio, Ravi Vedula, Lalith Suragani Venu, and Julie Schlepper. Our first speaker today is Rob Richardson, Global Business Director for Lubrizol Engineers Performance Apparel. Rob has a degree in chemistry biology and studied polymer science at the postgrad level at the University of Akron. He started with Lubrizol in 1991 and has 15 years of R&D background, including 7 patents. He has 19 years of commercial experience with roles in sales, marketing, and business management. Rob has managed Lubrizol's performance apparel business for the last 5 years. Go ahead, Rob.
Thank you, Lydia. First, I'd like to welcome each of you to our webinar. Thanks in advance for your interest in Lubrizol, our technologies, and our Innovation Alliance partners. I'm confident that the time spent with us over the next 60 minutes will be valuable, enlightening, and worthwhile. Second, I'd like to offer a personal hope that each one of you and your families are safe amidst the global pandemic that has impacted all of us in ways we could not imagine a year ago. Let's look forward to a brighter 2021. Lubrizol has been an innovator since its beginning in 1928. More importantly, a collaborative problem-solving company. We love to take on big challenges and work with like-minded people and companies to make a difference in people's lives. This has never been a brighter North Star than today. Our vision of move cleaner, create smarter, and live better encompasses all that we do and the spirit in which we strive to make a difference to our customers, consumers, communities that we operate in, and our partners. One thing that we have been working on in our performance apparel business for some time is improved sustainability. That started with inventing the first reactive extrusion elastomeric fiber with the tenacity and stretch performance required to enable the reimagination of stretch fabrics with a recyclable fiber that also enables the recycling of fabric waste, our topic today. This has been a journey, beginning with imagining a zero waste process internally, then outwardly by collaborating with our partners and brands to imagine a world without waste at the fabric and garment level. We have a vision towards this and are helping build programs and a supporting ecosystem of partners to enable this with and for brands. In 2021, we'll see the first launch of a garment line created based on circularity. That is pre-consumer waste, and it will be extended to post-consumer recycling over the life cycle of the garments. We know we can't do this on our own. That actually excites us as we share the vision and work towards a more sustainable industry with like-minded brands and partner companies. We are proud to have a broad range of sustainable material solutions for apparel that span fiber, adhesives, films, foams, coatings, and even cosmetic textiles. In addition, we are constantly evolving applications and test methodologies to deliver unique fabric and garment performance in a demonstrable way. Over the next hour, you will learn more about these from a great team of people that I'm proud to be a part of. I think you'll also feel that we go about our business in a different way. Our Innovation Alliance partners are incredible and bring fabric and processing knowledge to bear that make our overall innovation capability truly special. I hope we can encourage you to let us put it to work for you. Again, thanks for engaging with us today, and I hope this session is both inspirational and meaningful. We look forward to what comes next. Together, let's imagine and, more importantly, help create a world without waste. Thank you.
Thank you, Rob. Let's move on to our next speaker, Lisa D'Onofrio. Lisa is Program Manager for Performance Apparel in Lubrizol's Engineered Polymers division. Lisa spent the first part of her career in corporate travel, joining Lubrizol in 2003 as Travel Analyst and Procurement Card Administrator. In 2007, she transferred into marketing for Engineered Polymers, with a shift into performance apparel in 2012. As Program Manager, Lisa's global role oversees customer programs, manages sales and operations planning, and supports marketing and communications. Take it away, Lisa.
I have the honor of speaking about our Innovation Alliance partners. They are leaders in fabrics, elastics, and garment innovation. They serve global apparel brands who are asking to bring something unique to the market. Speed of innovation is a key focus for both Lubrizol and Alliance partners. We understand the importance of timely delivery of current products and new innovation to the global apparel market in order to stay current with consumer needs and the focus on sustainability. Innovation cycles are typically 2 to 3 years, but the value of these partnerships has taken innovation timing down to 1 year from concept to launch. To overcome the challenge of taking a chemical company into the textile world, Lubrizol's strategic alliance with value chain experts provided the path for taking the material science technology of X4J, TPU fiber, and other solutions to the apparel market, delivering enhancements that takes performance to the next level. The key benefits brought to life in apparel made with X4J fiber are comfort, stretch, soft hand feel, and the non-binding power of shaping and durability, to name a few. The X4J made garments provide wearer confidence with unique enhanced performance for greatest consumer appeal. More on the benefits of X4J will be presented by our next speaker. Now, to introduce Alliance partner experts, starting off with our fiber spinning partners. Changwon Elastin, referenced as CY, is based in China and has been a long-time innovative partner. As business with X4J grows, CY increases capacity with continuous improvements of production processes and quality. Premier Fibers, also a longtime partner, is our spinner in the U.S. Premier continually innovates and improves to provide customers with a broad range of nylons as well as X4J fiber. Moving on to our fabrics and elastic partners, starting with experts in knits. Rutai is a circular and warp knit company based in Taiwan and in Thailand. Rutai has innovated a full range of stretch fabrics made with X4J. Their fabric selections include functional, fashionable, and environmentally friendly styles, and the process is completed with in-house dyeing and finishing. Hornwood is a U.S.-based knitter for the athletic apparel, footwear, medical, defense, and automotive markets, servicing brands globally. From warping and knitting to dyeing and finishing, Hornwood's fabric innovation includes X4J fiber for a sustainable solution in high-performance fabrics. Polartec, a division of Milliken, is based in the U.S. Polartec creatively takes the science of fabrics into unique designs, which line up with X4J in eco-engineered performance fabrics. Polartec is committed to solving problems and promoting industry-changing ideas. Next in our lineup is a narrow elastics and stretch lace. Stretch line of MAS Holdings in Sri Lanka has been a longtime partner of Lubrizol for innovations with X4J, mainly in intimates apparel. Stretchline produces unique X4J narrow elastics in 5 regional locations: Sri Lanka, China, Indonesia, Latin America, and the UK. Noyan Lanka, also of MAS Holdings, produces knitted lace in multiple forms. The lace made with X4J has a soft hand feel with an easy stretch, giving intimates wear and other apparel a beautiful look with a comfortable fit. Next, we have X4J innovation in seamless knits with our Israel partners. Tefron is revolutionizing seamless fashion and performance with groundbreaking new ideas, helping customers develop innovative products, technology, and beauty. Comfort stretch with X4J in seamless fabrics is the added value that leading brands can recognize and appreciate. Delta Galil runs strategically located design, development, and manufacturing centers around the world. The comfort, aesthetics, and quality of their seamless fabrics showcases the performance and comfort of X4J stretch fiber in intimates wear. In denim and cotton-rich woven fabrics, success is attributed to denim expert Ola Inc., our sales agency partner based in New York City. Their network of denim mills is strategically located in different regions of the world. One key mill is Prosperity Textile in China. They create innovative denim fabrics with in-house weaving, dyeing, and finishing. X4J in denim provides a comfortable stretch, adaptive shaping, soft hand feel, and no bagging at waistband and knees. Woven stretch fabrics with X4J are developed by the next 2 partners. Scholler Textile of Switzerland creates innovative performance fabrics for outdoor, sportswear, and lifestyle apparel. The X4J stretch wovens enhance protection and support and are ideal for fashionable apparel with functionality. Apex Textiles in China meets design challenges to develop the right solution for customers and has created high-performance fabrics with X4J. Yarn covering experts are next. Felix in France and China specializes in elastic yarn covering, offering highly skilled processes that bring value to the apparel, industrial, medical, and protective markets. Combining nylon with X4J has opened doors in unique solutions for hosiery and other applications. Success is proven in the launch of hosiery under Hanes brand's DIM in 2019 at retailers in France. We're proud to share a testimonial with you in this next clip given by Antonio Iandolo, the VP of Hanes Europe Innerwear.
Thank you so much, X4J. X4J is a key component of our Dim Perfect Compression pantyhose, a ultra-stretch revolutionary fiber, an innovative technology specifically intended to make legs feel lighter without constraining them. Tireless legs, jambes infatigables in French. Thank you very much, Lubrizol.
Sapona, as part of McMichael Mills in the U.S., specializes in stretch yarn covering and produces fine quality yarns using state-of-the-art texturing machines. Their X4J covered yarn gives an easy, supportive stretch that's found success in sock programs. Next, we'll feature our garment partner in Hong Kong. Clover is an expert in bra manufacturing and other intimates and athleisure garments. They endeavor to be the preferred partner to the world's leading intimates brands. Clover's cutting-edge styles and designs partner well with X4J fiber for performance and sustainability. Now comes Recycle. Lubrizol is closing the loop in circularity with an Austrian-based textile equipment recycler, Pure Loop of the Arima Group. Pure Loop has developed a shredder extruder machine that recycles pre- and post-consumer waste, which aligns perfectly with Lubrizol's sustainability initiatives. X4J fabrics with nylon have been successfully recycled into pellets, which are then ready for repurposing. As a testimony to that repurposing, our partner Utax in Japan has used their expertise with injection molding to process the recycled pellets into a bra underwire and other accessories. As a final comment, success with our partner network is evidenced in the reduction of the development cycle. From start to finish, fiber production to the recycled bra underwire, the time involved is about 18 months. To meet with Lubrizol's performance apparel team and alliance partners, contact information is available on our show landing page. Thank you.
Thank you, Lisa. Coming up, our Global Market Development Manager for Fibers, Ravi Vedula. Ravi completed his PhD in Physical Chemistry, Membrane Science from Clemson University in 1990 and has been a member of the Lubrizol family for 28 years. From synthesis to application development, Ravi has spent his first 16 years in research and development. While working at Lubrizol, he graduated with an MBA from Cleveland State University. And the last 12 years, his primary focus has been to develop new fiber technologies in partnership with select innovators in the textile industry. He holds 17 patents in polymer synthesis and fiber technology. Over to you, Ravi.
The addition of stretch to clothing in the later half of the 20th century, first by rubber and then by spandex, set the apparel industry into overdrive. The concept of mass customization, introduced by stretch fabrics and garments, where one garment fits multiple sizes, increased manufacturing needed to clothe an exploding global population. But there was a problem. Spandex cannot be thermally recycled. No doubt, stretch garments answered the basic needs of an emerging active lifestyle, but it completely ignored the increasing environmental waste problem it created, where all stretch fabrics and garments ended up in a landfill. The problem that was created by the thermoset stretch fiber spandex was that it could not be recycled along with its thermoplastic counterparts in a fabric, nylon and polyester. So when combined with spandex, these otherwise recyclable fibers, in effect, lose their ability to be recycled from fabric. The thermoplastic nature, or simply put, the ability to melt and reshape of X4J fibers provides the one key ingredient to answer the environmental call. Fabric and garment innovators can now design, stretch garments that provide significant and measurable comfort to the consumer, be it for a striving athlete or for an all-day functional garment. All this while enabling the complete thermal recycling of waste to other productive uses and thus avoiding landfill. Let me take you deeper into what this technology really does for apparel. Our active lifestyles today demand an enhanced level of comfort from garments under very different physical conditions, from the gym to the workplace to an evening get-together. Words such as comfort and confidence have become the emotional descriptors of consumer demand, while the word sustainability has become the call to action. Long-lasting, breathable, soft fabrics that stretch easily to shape while enabling the recycling of garments is a core mantra of the X4J technology. Comfort for all body shapes and sizes, to be able to wear the garment for a workout and then go grocery shopping. The stretch fiber has to allow the garment to expand and contract without feeling restrictive, just like a second skin. Typical spandex fabrics, described by the blue curve in this slide, show an exponential rise in force when stretched. This results in the garments feeling restrictive and tight. This is a fundamental flaw that X4J rectifies. The flat stretch to force ratio, shown in red in this slide, is the key to the comfort felt in garments containing X4J. Narrow elastics, the Fit J line, from our partner's stretch line, illustrates the J effect very well. To provide comfort and confidence, a waistband elastic needs to adapt to multiple shapes of the body, as well as changes in shape that occur during a day. The longer the force line, shown in the graph on the right, stays in the comfort zone of body stretch, the shaded area between P1 and P2, the more comfortable and confident the consumer experience. This is the bedrock of the X4J technology. But for today's lifestyles, a flat modulus curve alone doesn't meet the needs of the body. The ability to offer sufficient and distributive compression is vital for muscles to recuperate. Limiting excess vibrations and lactic acid buildup is key to faster recuperation. But compression garments are cumbersome to put on. As the garments are well under body size on the hanger, X4J offers a unique combination where this easy stretch in the XY plane, as shown in this slide, a reminder of what we saw minutes ago, is combined with higher compression in the Z direction, that is the direction perpendicular to the skin and into the body, where compression really performs. Let's observe this effect more closely. This slide, which shows in 3D compression measurements of a typical spandex-containing fabric. The measurements are made with a plunging pressure sensor through a fabric with a pre-stretch of 30%. This to simulate a typical hanger-to-body expansion of the garment. Let's compare this to fabric with X4J, shown in this slide. The higher compression from an X4J fabric can be seen from the larger pyramid in the center. The larger 2D footprint of the X4J fabric, seen on the right, shows the pressure being distributed over a wider area in X4J garments. This results in higher compression without the feeling of restriction. The flat curve in the XY plane, shown previously, combined with a higher distributive compression, results in garments that are not only easy to put on, but complement body shape, as shown in this slide. A 3D body scan of a 40 to 50-year-old female subject in a pair of denim jeans. The picture on the left is a subject in a pair of jeans containing spandex, and the one on the right with the subject in a pair of jeans containing X4J, both with identical constructions. The distributive compression is evident in the picture on the right. The muting of bulges and smoothing of creases by the X4J jeans is visually evident. Through the ages, soft fabrics have always been viewed as premium offerings. This is because the human body is very sensitive and discerning regarding the haptics of fabrics, especially when it's next to the skin. This picture shows the magnified surfaces of two fabrics, which differ only in the nature of the elastic element. The picture on the left is an X4J fabric, while the one on the right is an identical construction with spandex. The bottom graphs are a two-dimensional depiction of the same data. The absence of ridges and the overall smoothness observed in the X4J fabric is quite noticeable and explains the soft and premium feel. Ability to cope with climatic variations such as sweating is essential to the all-day stretch garments required by today's lifestyles. Due to its chemical and physical structure, X4J imparts faster drying to fabrics and cools the body during exertion, both of which maximize performance. The pictures in the slide, taken with a thermal camera, clearly show the cooling of X4J fabrics, shown in the bottom half, as compared to the spandex-containing fabrics shown in the top half, both before and after a treadmill workout. Let's not forget that the body is a keen and discerning participant. Fit, compression, haptics, drying, cooling are all inherent benefits from X4J. But that's not enough. True sustainability starts from enhancing the usable life of the product. X4J is unmatched in strength amongst elastic fibers, on an average 50% stronger. Combine the strength with high air permeability, and you have garments that last long and spend more time on the body than in the closet. How does this all happen? What makes X4J exhibit these properties? Let's go deeper and look at the physical structure of the fiber compared to standard industry fare. Unlike traditional elastic fibers, X4J is a monofilament with an ultra-high chain length. The monofilament morphology, the solvent-free production process, allow for the incredible high polymer chain length and tenacity of X4J. Add to this a low moisture absorption chemistry, and you have the foundation of this unique technology. But X4J continues working long after it has been discarded. In fact, its journey has just begun. Answering the environmental need, a primary reason for the development of this technology, will be discussed next. Thermoplasticity, the ability to melt when heated and reform on cooling. X4J belongs to this category of polymers, just as its non-stretch fabric partners nylon and polyester. Utilizing this common ability to melt and reform not only eliminates waste during fiber production, but also during fabric and garment production, and opens the door wide open for post-consumer recycling. Let's first see how fiber can be recycled back into fiber production in this next video. This sets the stage to address the larger problem of fabric and garment waste, the ability to melt along with nylon and polyester, and then utilizing the resultant composite to produce a variety of articles. This is the road that channels away from landfill. The next video demonstrates how this is done. Recycled composite chips from fabrics and garments can today be molded into trims and accessories like bra underwires, designer iframes, hangers, etc., thus extending the use of materials for many, many years to come. The close partnership between value chain innovators and brands opens a new era of inclusive, speedy development designed to eliminate the journey to landfill. These new benefits of X4J demand new test methods to adequately quantify them. In many applications, existing test methods fail to measure what the body experiences with an X4J garment. The next session walks you through advances in testing that are tailored to measuring the effect on the body.
Thanks, Ravi. Our next speaker is Lalith Suragani Venu, application scientist. Lalith holds a PhD majoring in fiber and polymer science, specializing in nonwovens at North Carolina State University, and a bachelor's in textile technology from Osmania University in India. Prior to Lubrizol, he was a product development engineer at Alstrom Nonwovens in the medical and food business group. Lalith is focused on developing thermoplastic polyurethane fiber technology platforms and applications for the apparel, footwear, industrial, medical, and electronics market segments. He creates new characterization tools and techniques to strengthen the value proposition of fibers, fabrics, and garments to assist in speed to market. The floor is yours, Lalith.
You have heard my colleagues sharing details about Lubrizol, vision, pioneering fiber technology, enabling stretch fabric recycling, and how engaged we are in the textile community. What I'd like to focus for next few minutes is beyond the fiber technology on how our fiber offerings, when made into fabrics or finished articles, are differentiated. Beginning with the discovery of silk to recently nanotubes, each fiber is unique and offers competitive benefits over their precursors in the market. With brands and applications looking for performance improvements in garments, it is no surprise that high interest surrounds materials which bring greater differentiation in function and design. As researchers are constantly working on inventing raw materials and fibers, their significance is only demonstrated and differentiated when characterized. Characterization can be with existing standards or protocols developed to suit the application. From our work, we share how existing methods were applied, modified, and new techniques were developed to interpret weight trials and assist in product development. These test methods include characterization from polymer, fiber, fabric, and finished garments. I'd like to focus and share a few case studies on new test methods that we developed to support market segments. The first one being intimate apparels. Intimate apparel is perceived as second skin, where comfort and functionality are considered as pinnacle attributes. Continuous efforts are made by both academic and industry experts to hone performance and comfort and minimize any health risk associated with second skin intimate apparel, particularly in bras. One key bra design with detrimental effect on wearer health is compression coming from tight and narrow straps, which leads to shoulder and neck pain. To overcome this issue, strapless bras were designed and commercialized. A variety of them exists in the market, where one category may be too tight around the body and the other where the garment may just slide down. In these cases, there is no reliable test method to determine fabric gripping force offered by fabrics other than weight test trials to compare how well the garment is positioned. But weight trials have longer timelines, are cost prohibitive, and can be misinterpreted by anecdotal feedback. Thereby, a predictive test method is developed to characterize fabric slippage, compare fabrics, and decrease product development timelines. In our attempt to simulate wear trials, we measure the fabric gripping force as a function of fabric properties. As illustrated in the schematic here, A cylinder was covered with a sleeve of rubber nitrile to simulate shape, texture, and haptics of human skin, which was further covered with fabric material used in the bra construction at different fabric strains. This setup is mounted on an instron to determine the fabric gripping force. As the fabric is being pulled down at a rate, fabric offers resistance in the static region until it reaches a maximum force referred as threshold of motion as shown on the right. In this static region, fabric or garment doesn't slip. But when the force is continued past this threshold, fabric starts sliding into the kinetic region, representing the fabric slip. Thereby, with this approach, we understand when fabrics or garments start slipping on the body. This phenomenon has been crucial in engineering fibers, fabrics, and demonstrating differences in these materials as a function of the fabric strain. Thus, technique can be used to compare and predict wear trials. Here, we compare two fabric constructions where one exposes fiber X4J and the other doesn't. Scanning electron microscope graphs are shown here and illustrated. Top left micrograph shows X4J fiber hidden within fabric construction versus the bottom left shows X4J fiber exposed on the back, seen as the thick continuous filaments. This is the side which will be in contact with the skin and the rubber nitrile in our case. Applying the previously described technique, we show how fabric construction with unexposed fiber requires less force to reach the threshold of motion and thereby easy sliding thereafter, as illustrated in figure A. Whereas fabric with exposed X4J fiber requires 4 times the force as the other to reach the threshold of motion, and thus providing resistance for fabric to slip as seen in figure B. This trend of higher force with exposed fibers is consistent in both relaxed and pre-strained fabric states. In this way, we were able to characterize the fabric slip and differentiate the differences. Further, the validity of this technique was confirmed by brand wear trials and ultimately shortening the product development timelines. Thus, this approach can be used by material developers, fabric manufacturers, technical designers, and brands to predict wear trials. During any wear trial or body motions, garments experience low to high stresses at multiple locations, resulting in fabric deformation. Common locations are noticed at knees, elbows, and back, especially during knee and elbow bending and while sitting and regaining standing position. Thus, it is essential to choose correct stretch compression garment with correct contact pressure, as insufficient pressure will limit efficiency and aesthetics, and too much pressure results in fatigue. Thus, a valid technique to measure compression or fabric contact pressure in dynamic state is needed, which is demonstrated here. To replicate such conditions and to measure force exerted by compression garments on contracting muscles, a cylinder which can expand and contract in radial direction was developed. Provisions have been made to accommodate pressure sensors on its surface. Further, this cylinder is covered with a sleeve of fabric, a gray color one in this case. With repeated motions of an impactor, not shown in the video here, cylinder expands and contracts, and so does the fabric as shown in the video. As a result, pressure exerted by the fabric is measured via the transducers during these cycles and visualized on the right side in real time. Visualizations show amount of pressure exerted by fabrics in 2-dimensional and 3-dimensional formats. The 3D peak on the right represents highest pressure offered by fabrics, and the width of that peak in 3D window represents how the pressure is distributed away from the center. On the bottom, chart shows pressure as a function of time, with each peak showing the cycle of expansion and contraction. Thus, this approach allows us to visualize differences within a fabric in dynamic state compared to materials and help in engineering the fabrics prior to conversion into compression garments. Here, we show a comparison of two different elastomeric fibers, X4J and spandex, when other parameters like fiber content, fabric geometry are kept constant. In this example, fabrics have 5 cycles of expansion and contraction, with no difference between the first and the 5th cycle. However, higher amount of pressure and broader distribution of the contact pressure is offered by the X4J fabric, implying a balanced distribution of pressure or even compression as compared to generic spandex kind, thus differentiating compression or contact pressure offered by fabrics in dynamic state and predicting the compression attributes of materials and garments made thereof. To take the characterization to next level, here we show some preliminary findings. Here we have a test method which is customized to simulate real day-to-day activities. With this approach, fabric deformation during knee flexing can be visualized, and garment deformations like bagging at the knees can be characterized for the very first time. In this approach, knee flexing was carried out to 3 flexion angles to represent common activities like tying a shoelace, riding a bike, and squatting. As a result, amount of force exerted by the fabric is measured, indicating higher forces experienced by the fabric during squatting versus cycling versus tying a shoelace. In this way, we customize test methods to address the unmet needs in the market, demonstrate and strengthen the value proposition, work with our alliance partners to innovate and build your confidence as a wearer. Hope this session was helpful and looking forward for our discussions. Thank you for your time.
Thank you, Lalit. And now for our final speaker today, Julie Schleppert, Director of Sustainability and Communications for Lubrisol's Engineered Polymers business. Julie has an extensive background that spans from fast-moving consumer goods to specialty chemicals and polymers, serving a broad range of industries. She has worked for Lubrizol Advanced Materials for 18 years. Go ahead, Julie.
Thank you, Lydia. Hello, it's my pleasure to speak to you today about sustainability at Lubrizol. Our mission to move cleaner, create smarter, and live better encompasses everything we do at Lubrizol, from our business strategies and operations to corporate responsibility and philanthropy through the Lubrizol Foundation. Our view of sustainability includes employees, customers and supply chain partners, and consumers, and all of the communities in which we operate. We are purpose-driven, with 3 major goals that span the business and which help us deliver against the United Nations Sustainability Development Goals, or the UN SDGs, where we believe we can have the greatest impact. With Move Cleaner, we aim to enable a 50% reduction in vehicle emissions by 2040, employing our strengths in fluid technology, materials science, and end-to-end solutions in transportation. With Create Smarter, we're intentionally designing to ensure a 25% increase in the circularity impact of our products by 2028, Lubrizol's centennial. This is well aligned with the principles of circular design, designing out waste and pollution, keeping materials in use longer through durability that extends a product's useful life, and by repurposing waste, and also by increasing our use of responsibly sourced renewable materials. The markets we serve, from footwear and apparel to consumer electronics and specialty industrial applications, are actively seeking solutions that bring these sustainability benefits. With Live Better, we will improve at least 2 billion lives by 2028, and through our formulations and testing capabilities, market insights, and global scale, which we use to help our customers deliver essential products in personal care, health and wellness, pharmaceuticals, and medical devices. Underpinning all of this is our commitment to operating responsibly, considering both our footprint, that is, minimizing the impact of our own operations, but also our handprint, maximizing the beneficial impact our products have after they leave Lubrizol. At Lubrizol, operating ethically has been part of our culture since the company was founded, and our commitment to corporate responsibility has never been stronger. We honor our promises to environmental stewardship, social responsibility, and strong governance, and our promises extend right through our giving activities, where by 2028, we will give more than $20 million and 80,000 volunteer hours to organizations aligned with our community engagement priorities. Our 2020 corporate report details the company's vision and mission and brings greater transparency to our progress on sustainability. Our 2021 report will include new long-term goals endorsed from the top down. We're proud of what we've accomplished so far and excited about what's to come. A more sustainable future for Lubrizol, for our customers, and for the world. We invite you to join us on this journey in making a real and meaningful difference. Thank you.
Thank you, Julie. This brings us to the end of the presentation. For any questions, the Lubrizol team and partners will be happy to meet with you. Please request a meeting by using the contact information on the ISPO landing page. And more information can be found on the website links shown here and on the landing page. Thank you for joining us today.